Hello everyone, welcome to this course on File Storage Service. My name is Rohit Rahi and I'm part of the Oracle Cloud Infrastructure team. In this course, we will look into the File Storage Service and its various use cases. We will create, configure and mount a file storage service, and we will look into some advanced features like snapshots, security and export options for the file storage service. So before we proceed and talk more about the file storage service itself, let's look at where it sits within the wider portfolio of OCI Storage Services. We have been using this slide with the previous courses on the other OCI storage services. So as you can see here, file storage is an NFS v3 compatible file system. It's durable, meaning we maintain and manage multiple copies in an AD, in an availability domain. The scale is really high. We can it can support up to exabytes of file storage volumes, and the use case here is for applications that require shared file system. So these can be traditional applications like e-business suite, or these can be modern applications like high performance computing. So let's look at the use cases. One of the use cases we just talked about is Oracle e-business suite, and customers have been running EBS on premises using on-prem file system. For those customers, you can move those applications. You can move those applications to OCI and leverage the file storage service in the cloud. You can use FSS to replace your general purpose file system. So if you are using any kind of general purpose file system in an on-prem environment today, you can use the OCI file storage service to replace those general purpose file systems. You can use a file storage service for some of the newer workloads like big data analytics and HPC, and you can also use them for cloud native applications as well. What are the key characteristics, the key features of the file storage service? So the first thing is the service is AD local. It's AD specific service. So it resides in an availability domain. It supports, currently it supports NFS v3 protocol with support for things like file locking, full POSIX semantics. For data protection, you could use a feature like snapshots, and you can create up to 10,000 snapshots per file system. For security, we do encryption at rest out of the box, so you don't have to do anything. It's done for data at rest for all the file systems and metadata. You can manage the service using the console, API, CLI, Terraform, similar to how you would manage other services, and you can create 100 file systems and 2 mount targets per AD per account. And remember, this limit as well as the snapshot limit are soft limits, right? So you can always open a support ticket and increase these limits. The cost is really straightforward, and it's actually many times cheaper compared to the competing offerings out there. So before we go and we talk about the various capabilities of the file storage service, let's look at some of the core concepts, some of the key concepts we need to understand. The first one being mount target. We have been talking about this design for a while now in the other courses. So you have an OCI region here. A region is comprised of 3 availability domains. For the sake of simplicity, I am only showing 2 availability domains right here. Now the file storage service runs behind a virtual cloud network. So we create a virtual cloud network here, 10.0.0.0/16, and as you would recall, the VCN service is a regional service and it spans multiple ADs, multiple availability domains. So I have created 2 subnets here to further divide the network running in respective ADs. So you have subnet here 10.0.0.0/24 and 10.0.1.0/24 running in AD1 and AD2. Pretty straightforward network design. Now a mount target is an NFS endpoint that lives in your subnet of choice. You could choose the subnet, but it's AD specific. As you can see, this particular mount target is running in this AD1. Mount target has an IP address and DNS name that you can use in your mount command. So you see this IP address here, 10.0.0.6. Now you can create your NFS clients which can connect to this mount target, and you run the file system on top of the mount target. But there are some design considerations you need to keep in mind. So the first thing is the mount target requires 3 private IP addresses in the subnet. The first 2 IP addresses are used during the mount target creation, and the third one is used for HA. So a good design practice is to not use subnets which are /30 or smaller, because remember that in a VCN the 3 IP addresses are reserved. You cannot use them. And then if your mount target requires 3 IP addresses, 3 private IP addresses, you have to have a subnet which has at least 8 or more IP addresses, right? So don't go with subnets which are smaller than /30. Otherwise you will run into issues creating a mount target. Now there is another design consideration which is to separate the subnets for the mount target and the NFS client. As you can see here, the mount target here and the NFS client live in the same subnet, 10.0.0.0/24. That might not be a good idea. Let's look at why. So placing NFS clients and mount target in the same subnet can result in IP conflicts, as the users are not shown which private IPs are used for mount target. So earlier we said that the mount target private IP could be something like this, and the other 2 IP addresses could come anywhere from the IP range. We don't know what the service will select, and you cannot choose, view or edit these IP addresses. So it's a good idea to have a separate subnet for the mount target and have the separate subnet for your NFS clients, as you see here. Placing FSS mount targets in its own subnet helps it to consume IPs as it needs, as described here. So you don't really have to worry about it consuming IPs from your other subnet, and this NFS client, when you instantiate the instance, you can choose to give it a specific private IP address. So if you do that in those kind of situations, you can run into IP conflicts. So good practice, just separate out the subnets. That way you will ensure that you don't run into IP conflicts. Now, what is a file system? We saw that we created a mount target here in this particular subnet. A file system is a primary resource for storing files in the FSS, the file storage service. To access your file systems, you need to create a mount target, as you can see here, or you can use an existing mount target. You can create up to 100 file systems per mount target, and you can change that number. Mount target file system like mount target is also AD specific, resides in a particular AD, your AD of your choice. It is accessible from the NFS clients. They can be in the same AD, or it can be different AD, or it can be at completely different region, as well as on-prem. It can be an on-premises environment. Literally, it's basically it's running behind a VCN service. So you could create a DRG here, and you could connect it to on-prem environments, and these servers running in on-prem could access your file system running in OCI. Now there is something called an export path, which is a unique path specified when the file system is associated with a mount target during the creation process. Let me just show an example here, and then I'll talk about the best practice. So you have a mount target here, NFS endpoint. We looked at it earlier. When you are creating a file system, you could describe and give it a path here. So there's a path which says /example1/path, and the second file system can have a path like /example2/path. Now the thing to note here is these two paths are completely distinct. They are not overlapping. And this is the point I was making earlier. No two file systems associated with the same mount target can have overlapping export paths. So a path like example and example/path are not allowed because there is a conflict and there's an overlapping path /example being the overlapping piece. Shouldn't use that. It will give you an error. Now, what is the use of this export path? Export path along with the mount target IP address, this plus this, is used to mount the file system to an instance. Let's look at an example. As you can see here, I have the NFS endpoint IP address, mount target IP address. I have the path here, and these two together are used to mount the file system to an instance. So these are my mount points, my paths to the directory on the NFS client instance on which the external file systems are mounted. And because my paths are non-overlapping, I could run these commands and I have two file systems accessible through the same NFS client on two different mount points. So I could access them accordingly. Now FSS security has different distinct and separate layers of security which you could use when you are using this service. So the first thing is when you use any OCI service, you have identity and access management integration where you can authenticate and authorize the users or the groups who can create or use your service, right? So for example, you can have users and you can provide them access through policies to create FSS service. If you lock it down, you basically so you can have a group of admins who can manage, for example, who can create and manage a shared file system. You can have other people who can just use it. So you can work through all the different kind of granular role-based access control, and you can control these file systems like you would control any other service within OCI. There are two security features which are very specific to FSS on security list and export options. We'll talk about those in the subsequent slides. And then you can, like the identity access management service, you can also leverage NFS v3 Unix security when you are using FSS service. So you have Unix users and you can decide which Unix users can mount file systems, read or write files, what kind of access permissions they have. You could decide all that. There are certain considerations you should use when you are mounting file systems and the different mount options you provide, such as things like no lock, R size, W size, etc. The general best practice is to not use these mount options because of performance and file locking when using the file storage service. So let's look at the two distinct capabilities we talked about, the security list and the export option. So security list can be used as a virtual firewall to prevent NFS clients from mounting an FSS mount target. Even if they are running in the same subnet, it doesn't matter. Right here I'm showing two different subnets, but they could be running in the same subnet and this still applies. So you have a mount target running here, you have an NFS client running here. You have to create security lists and open these specific ports for TCP and UDP. If you don't open these specific ports, the NFS client cannot mount an FSS mount target, and it cannot access the shared file system. So this is how you would use the security list within the VCN. And right here you can see that I am, for this particular mount target, I am opening the traffic from this particular subnet right here, and I'm opening the traffic for TCP, a few 4 ports, and for a couple of ports for UDP. Now one of the problem you would notice in this graphic is if I have an NFS client right here in another subnet, I have to repeat the same thing, the ingress rule. And by the way, these are all stateful. It's actually not written here, but these are all stateful. I would have to do the same thing for this particular IP address or IP address range. If I don't want to do that, I could just go here and I could just change this to 10 dot. I could change all this just to the whole CIDR block 16, and now in that case my NFS client 2 and NFS client 1 would be able to access the mount target. But just keep in mind you have to open these ports, otherwise if you don't open the ports, your clients cannot mount these mount targets, cannot use the shared file system. There's also something called an export option. So think about this way, security list is all or nothing approach. The client either can or cannot access the mount target, and then therefore all the file systems associated with it. It's true, right? You have clients here, you are either blocking the whole client through this security list, or you are allowing them, right? Now what happens if you have a multi-tenant environment? You have multiple file systems running on the mount target. How can you limit clients' ability to connect to specific file systems and even go granular, whether they want to view the data or whether they want to write the data? So that is where the export options come into play. Export options control how NFS clients access file systems. Info stored in an export option includes the file system OCID, export path, and the client access options. This is really powerful. It basically tells you what kind of access I have. When you create a file system and associated mount target, the NFS export options for that file system are set to allow full access. So that's why you don't have to change this. It's set to allow full access, and it goes something like this. It says source everything, and a bunch of things here, access, read, write, identity squash, none, etc. right? You can change these, and let's look at a use case of why would you decide to do that. So as the previous examples, I have a VCN here. I'm just skipping the region and the IDs, etc., just to keep the picture simple. And so I have a VCN here, same as what we had earlier. You have a mount target. So I have a couple of other subnets, and I'm running NFS client here. So I have a client X running here, I have a client Y running here in each own subnets. Now I have a mount target here, and I have a mount target subnet, separate subnet, as we talked about. That's a design best practice. And I have a file system A running here, and I have a file system B running here, right? So I have two file systems running on the same mount target. I can have up to 100 file systems running on a mount target. In this case, I'm showing 2. Now let's look at some of the requirements. So the client X is assigned to this CIDR block. It requires read-write access to file system A, but not file system B. So it has a read-write here on file system A, but on file system B, it doesn't require any access. It should not have any access to file system B. Client Y, which is here, requires read access only, but no access to file system A. Read access to file system B, but no access to file system A. So a different requirement. You can see here it requires read, and right here for file system A, it doesn't require, it shouldn't have any access. So if you have a design like this, requirement like this, and given the condition that both file systems A and B are associated to a single mount target, you could use export options. Now today these export options are available only through the CLI or the API, and this is how you would use it. You would set it through, for example, I'm showing it through CLI. You would set the export option for the first client here. You would say this is my source ID, my source CIDR block, and your access is read write, and the read write access is to the file system A. For the second one, and you can see this file system A export ID here, right? You have to provide that. For the second one, you will give the file system B export ID, and you would say the access is from the second subnet 10.0.1.0/24, and the access level is read only. And so this will ensure that this client can access file system B, because the file system B export ID is here, and the access permission is read only. And it doesn't have access to any other file system. This rule will make sure that this particular client has access to file system A. You have file system A export ID here, and the access level is read and write. So remember, whenever you want to go granular with your access permissions, use a feature like export options. Now, how you can mount an OCI file system, right? It's very straightforward. You run few commands. You need NFS utilities. So you could install NFS client utility for Oracle Linux or Ubuntu or the other flavors of Linux you are running, and you can these are the commands you would run in order to mount an OCI file system. As we have said earlier, because of performance considerations, don't provide options like the options for the read and write window sizes, etc. Those are not really required. Now let's look at FSS access options. We talked about this very briefly earlier. FSS is an AD specific AD local service that can be accessed from all the ADs in the same region and by resources using the console API, CLIs, Terraform, etc. So you can access it locally. You can mount a local VM or a bare metal machine and use your file system. You could access it within you could have a remote AD access. So within a region, you could go to another AD and you could access the mount target. You can also do remote access, so you could access the file system from other regions, or you could use it from your customer on-premises environment as well. The last feature we really want to talk about here is Snapshot. Snapshots provide a read-only, space-efficient point-in-time backup of a file system, and snapshots are created under the root folder of the file system in a hidden directory which is named .snapshot. As you can see here, creating a snapshot is pretty straightforward. You go into the console CLI, just click say create snapshot, and the snapshot gets created in this particular folder. Now, what is the use of creating a snapshot? Well, you can restore a file within the snapshot, or you can restore the entire snapshot using the CP or rsync command, copy or the rsync command, and you would use a command like this, and you could restore a file within the snapshot if you file gets corrupted or deleted by accident, or you could restore the whole snapshot, the whole file system right there. If nothing has changed within the target file system and you take a snapshot, it does not consume any additional storage. So it's always incremental by default, and it doesn't do a full snapshot or full copy of your target file system. Now with that, we covered a lot of ground. Let's look at the FSS demo and look at some of the things going on there. So let me come out of my my PowerPoint slides. I go to my OCI console, and we have been using this console for our other we have been using this particular compartment for our other courses, and we will be using the same compartment for creating a shared file system service. So first thing I'm going to do is the FSS service needs certain prerequisites. It requires a virtual cloud network. Remember, we talked about that. It's running behind a virtual cloud network. As you can see in this training compartment, I have a couple of virtual cloud networks, VCNs, but let me go and create a new VCN in this in the same compartment. So I will say that this VCN is called FSS, and I'll call FSS VCN, and or let's say FSS VCN 1, and I for here I would just create a virtual cloud network because I have a specific design consideration. So let me just first create the VCN, and then I'll create the subnets, etc. So I create this this VCN. And now what I would do is I need 3 subnets. I need the first subnet for keeping my my mount target and the file system. So lack of a better name, I would say this is my FSS subnet. I would say this is FSS subnet, and I would choose this in 81, and I need to pick a CIDR block here. So if we go back to our slides, this is the CIDR block I had for my FSS subnet. So I'll use the same thing, it's fine. I can choose the default, and I'll change these later on. So I choose the default security list and the route table, and I'll choose a private subnet here, because remember, this is my file system. I don't want it to be publicly available, so I don't want it to be in a public subnet. I'll make a private subnet, it's completely fine. So I create this first subnet, FSS subnet, which is my subnet where I would keep the mount target and the file system. Now I need to create two additional subnets for my NFS clients. So I would say NFS 1 subnet, and this will be in 81, and I need to pick my CIDR block. I would say 1.0/24. Default route table is fine. We will change these anyways. And default security list is fine. Now this one can be a public subnet, because this is where my NFS client is. If I wanted to use a bastion host, I could use that. I could make it private as well, but just to keep it simple, public is okay for the client. So I create my first subnet, and then let me create another subnet, this being my second client, NFS2, and this would be in let me just see the name here, NFS1 subnet. Okay, and this would be in 82. So I have two clients, one in 81 and the second client would be in 82. So I choose 82. I need to provide CIDR block for this. So I would say this one was 1.0. Okay, so I need to say NFS2 subnet 82, and this would be 3.0/24, and default route table and default security list is fine, and the public subnet is fine. So I create this. So I create the FSS subnet where my mount target will be, and I have two clients, one running in 81. So I'll create a client in 81, and the other client would be running in 82. So I got that 82 client subnet as well. Now I need to do a couple of things here really quickly. First thing I need to do is I need to go into security list, and I need to create a new security list. So because FSS uses its own it has its own requirements for opening certain ports, so I would call it the FSS security list, and right here I would open it up for the entire VCN, because remember when we were discussing on the slide, we said that you have to open the ports for specific CIDR blocks, so your clients can access the mount target and the file system, and I could do that one by one for every client subnet, or I could just open it up for the whole CIDR block, for the whole VCN CIDR block. So that's what I'm doing here. I would say IP protocol is TCP. IP protocol is TCP, my source port is all, and my destination port is, I have to do 248, 249 and 250. So I would do that really quickly. I would do the same rule. This time I would say TCP port 111. I would do another one, same CIDR block. My port is UDP, my protocol is UDP, my port is 248, and then I have another rule, my protocol is UDP and my port is 111, and the egress, I need to allow all the traffic out here. Let's say all protocols, and that's fine. So I create this security list here, right? And I'll show you what the security list looks like. Basically we are opening port 20484950 for TCP, and we are also opening port 111 for TCP. For UDP we are opening port 2048, and we are opening port 111. Remember, these are the requirements for the subnet where you are going to run your mount target and the file system. Now, one thing I need to do is I need to go back to my virtual cloud network and pick up my FSS subnet. And right here, before I do that, let me create a route table as well. So I would create a route table for my mount target, and I'll keep it empty right now because this is, remember we said this is a private subnet, and I could take it to, you know, like an on-prem environment, or I could, you know, use like a NAT gateway or something. But for right now, let me just have nothing in here. It's empty, so it's sort of not going out. It's not sending traffic packets out to on-prem environments or internet or anything like that. So for my default route table, I need to add a rule because it doesn't have a rule here. So I'll create an internet gateway, because remember I have two subnets where I'm going to instantiate clients, and these clients we will access them through SSH, so I should be able to connect to them. So I created an internet gateway, and now my default route table, I'm going to edit the rule. Oops, sorry. I click here, I choose my target is internet gateway, send all the traffic out for all the IPs on the web. I use my internet gateway, I save it. Last thing I need to do is I need to go back to my virtual cloud network and click on my FSS subnet. This is where my mount target and the file system would be, and I need to edit it. And remember, we talked about this in the VCN course. You can change your route table and your security list after you have created your subnets. So right now, when I was creating these, before I was creating this, I used the default options. I don't want that. I don't want the default route table, because this route table is taking packets to the internet. I don't want that for the subnet where my mount target is. So I will pick this empty route target table which has nothing in there, and for security list I would pick the specific security list where I made the changes. So I would say the FSS security list, and I will update this particular subnet. So this is my prerequisite for the network. I created a network, 3 subnets in there. One is for the mount target, 2 are for the NFS clients. These NFS client subnets are public. The mount target subnet is private. And I changed my security list for the mount target to allow traffic from these CIDR blocks and these ports and these protocols, right? So I did that. So this is all the prerequisite I need to do in order to create the file system. Now I get into file storage, and as you can see here, there is nothing which is available. So I would click on the file system, and I will create a file system here, right? So it says which compartment I want to use. Training is fine. It's giving me an optional name. I could use something like, let me just make it simple. I would say FS file system 1, right? And then it says it says which AD you want to use. I want to use AD1, and then it's giving me a mount target name here, and I can change these. So I click on edit details, and it says, do you want to use an existing mount target? I don't have an existing mount target here, right? You can see that there is nothing which exists here, so I can create one. Now it's giving me a sort of a cryptic name. I could say mount target 1, MT1, and then it says, where do you want to instantiate this mount target? So this is the network we just created. Remember, we just created this network, and then it says, okay, which subnet? NFS1 subnet is the wrong subnet. This is where my NFS client will be. So I pick the subnet where we really want this to be, which is FSS subnet. So choose this. And now all the options look good. My name is FS1. My mount target name is mount target 1. It's a new mount target. It's behind this network. And this is the subnet in which the mount target is existing. I can click on advanced options, and I can change things like, you know, IP address, host names. I can choose the path. I can change it. I can really have a lot of things which I want to customize. I can customize them here. Now this all looks good. I'll say create file system, and my file system would be created. And as the file system gets created, you can see the option for the mount target, and you would be able to see the commands which we need to run in order to mount this file system. So if I click here, I can see that there is a mount target here, mount target 1. The path is right here, and I can see the private IP address here, right? So this is the IP address which the system chose for me. I didn't really choose, and this is the point where my NFS endpoint is running, my mount target is running. If I click on this ellipsis, I can see the mount commands, and these are the commands I need to run in order to connect to this file system. So before, the last step for us to really test it out is to spin up a couple of instances really quickly, right? So I come here into compute, and this is my NFS client 1, say NFS 1 is fine, VM is fine, 1 CPU is fine. I choose files here, my SSH key. Now it's saying which network I want to use. So this is the same network, perfectly fine. And because it's 81, I pick NFS 1 subnet. I could change that from 81 to 82, and it would choose a different different subnet for me, right? So let me create my first compute instance, and then let me spin up another compute instance which becomes my second NFS client. And what we will do is we will have both these clients write to the same shared file system. So let me go back here, and I would say NFS2. Now this one I want to spin up in 82. Everything else is same, it's fine. Let me pick up my SSH keys. Now you can see that because it's 82, it's picking up the NFS2 subnet, the subnet in the second 80. So I click create here, and this would take around 30 seconds or so to spin up. And as soon as this comes up online, I should be able to connect to these instances and run the bunch of NFS utilities, the client utilities. So looks like the first client, NFS client 1, is online now. So if I try to SSH into this instance, there you go. So I am inside this instance, and the next thing I need to do is I need to go back to my file storage service I just created, look at the mount target, and then look at the mount commands, and I need to run these commands. So the first thing I need to do is run the NFS utilities. It's actually installed because I'm using the latest version of Oracle Linux. I need to create a directory, a local directory, and then I need to run the mount command to mount the file system to my local directory. So as I do that, you would see that the first thing is the command runs. So this shows that my my security list is working. If my security list was not properly configured, this command would hang because I would not be able to mount my client to the shared file system. Now I can go to this directory, where local directory on my machine, on this instance, on the NFS client, and I could create a file. Let's call it one.txt, and I am instance 1, and we could actually write to this file, right? And you can see that the first NFS client has written, it says I'm instance 1. Now if I go back to my compute compute service, I can see my NFS client 2. and let me SSH into my NFS client too. So I need to get the public IP address here and go to git bash, SSH into that particular instance. So this is my second NFS instance. Now this is running in 82. This is not in 81, right? The first one was in 81. This is in 82. So if I go back to my file storage and I bring up the mount commands again, because I need to run the same thing there. I'm not going to install NFS utility because it's already installed. I would copy the local directory creation command, paste it here, create my local directory, and then I would go and I would mount this to mount the file system to this directory. So I click here. Again, the good thing is it's letting me run this command, meaning the security list is properly configured. Otherwise it would have hung up here. It wouldn't have let me proceed. So if I now go to this mount target, first thing I could, if I do a listing, I can see there is a file called one.txt which we just created from the other client, right? It says I am instance 1. Let me go and change this file. Sorry. I can come here and I can say I'm instance 1. Now I am instance 2, right? And now you can see if I do a cat of this command again, this file again, I can see that my instance 2 is written. And if I go back to my first client and run and do the same thing, I can see that the second NFS client has written to this file. So what in essence is happening here is I have this first client, here it wrote this in a shared file system, and then the second client went to the same file system and it wrote this particular line, right? Very simple example, but it's hopefully showing you how we have a shared file system, and the shared file system is used across the two clients in two different ADs. In reality, what we just went through is this slide here. We just went through this example. We spun up a mount target and a file system here. We created a file system and a mount target. We had two clients, one in 81, one running in 82, and both were simultaneously able to write to this shared file system. So that's pretty much the demo on FSS. Let me just wrap up this course with the final piece on pricing. The pricing is very straightforward. You can see here much cheaper than many of the competing offers out there. Snapshots are space efficient. Customers are charged based upon the amount of changed data in the snapshot. So if nothing changes, snapshot is incremental and it really doesn't charge you any money. There is no charge for data transfer between availability domains within a region as well. So to summarize, OCI File Storage Service provides a fully managed, elastic, durable, distributed, enterprise-grade network file system in the cloud. Today we support NFS v3 and support various features like snapshots, data at rest encryption, security list, export options, various security mechanisms. It's highly scalable. You saw the scale can run into exabytes, and it's highly performant. NFS supports 4 distinct and separate layers of security, and we went through what those security layers look like. With that, thank you very much for attending this course on file storage, OCI File Storage Service. I really hope this was useful, and I look forward to seeing you in the next course on OCI Object Storage Service.